Now we find inverse of modulo class. Inverse of modulo class. What's the definition says? You consider A congruent to mod n. Consider A congruent to, this is called modulo class. To this modulo class, I want to find inverse. X is said to be inverse of this modulo class A congruent to mod n. A, carefully see now, see how it can be converted. This is called mathematical modeling. Ax is congruent to 1 modulo n. This is the beauty. So, what is the previous topic? Linear congruent equation. What is the linear congruent equation? Ax congruent to b modulo n. Same expression I got. Now, how you got the solution now? Get the GCD between these two. See whether that divides n. If it divides n, you have good number of solution. It won't divide, no solution. If the GCD is 1, you have unique solution. What is the GCD between the given number and 1? The GCD of 1 and any number is always going to be 1. See, A and 1, always GCD is 1. Once the GCD is 1, only one solution you can find, which is according to my classical linear algebra. In every group, the inverse element is always unique. Indirectly, we are getting that property under even modulo class. So, you are finding x an inverse of a modulo n, which should be unique, and GCD of 1 comma n equal to 1, you can find only one value of x, hence uniqueness is proved. Now, you know how to run it now. I have three approaches. One is either go for inspection or go with a modeling or go with what? Extended Euclid algorithm to get your x, which is going to be x naught, which is the inverse of what? A mod n. I'll go with one or two examples. Particularly, I want to deal one or two examples in this case. Once you understand the getting of inverse, your Chinese remedial theorem becomes a baby's game. Easily you can enjoy. Okay. After that, linear Diophantine equation. If time permits, I'll go with one application, that is cryptography. Then I'll wind off my session. Very, very important. Very, very important. Understand very neatly. Anybody who want to have good control on number theory, you should understand getting the inverse. Find the inverse of. Find inverse of 27 mod 392. So what we do now? We convert this particular problem into mathematical modeling called linear congruent equation. Let x be inverse of 27 mod 392. Another way of writing, we can write x is equal to 27 raised to minus 1 mod 392. This is one and the same as when you multiply 27 to x, I should get 1 mod 392. So this is a linear equation. Don't check whether there is a solution or not. Always solution exists. Because the GCD is always 1 and 1 divides every number. Since 1 divides every number, always there will be a solution and you can find unique solution. So this has unique solution. Don't check whether it has a solution or not. When you go with the inverse, always you can find the solution. Now how to find the solution of that? Now, Get the GCD of these two numbers. Carefully see now. The technique will slightly changes. Take the number 27, take the number 392. What is 27? The given number. What is 392? Modulo class. Get the GCD between the given number and the modulo class for which I want to find the inverse. We'll go with this now. Step number 1. I want to find the GCD of what? 27, 392. What is a better approach? When the number is too small, classical approach. When the number is quite big, always you can go with extended Euclid algorithm. It is going to be like. So observe carefully and go through, glance neatly. Nothing will confuse you. It is B, it is A, it is Q, it is R. We can write R equal to B minus. My tabular system clearly make you to understand. The easiest way, and nowhere this approach is there. So you can go once or twice, and 200% you can find these approaches are very easy. Bigger value 392, smaller value 27. I am ready with solution because I don't want to waste my time. Yeah. So Q equal to 3, R equal to 12. I can write 12 as it is 120. I have to get different problem. So I will take 37. So find inverse of 37 under modulo 123. X be the inverse of 37 modulo 123. So X is equal to 37. Yeah, it is 37 inverse. 37 inverse modulo 123. Modulo 123. That means it is going to be 37 times X is congruent to 1 modulo 123. Now I want to find the GCD between 37 and 123. What is the bigger value? 123. What is smaller value? 37. So what is the quotient? 3. What is the remainder? 12. Now we can write 12, we can write 123 minus 37 times 3. This is extension Euclid algorithm. Now you push A, push R. Again the quotient is 3. The remainder is 1. We can write 1 equal to 37 minus 12 times 3. Again push A value, push the R value. Here the quotient is 12, the remainder is 0, and we don't want this. Moment you get the 0 as a remainder, you need to stop there and go to previous non-zero value, that is going to be GCD. GCD is 1. Therefore, the GCD of 37, 123 equal to 1. Once you get the GCD, once you have the confirmation that GCD is 1, immediately I can think of what? The inverse. How to go for inverse? Linear combination. Linear combination, take the last column and go down to up direction. Consider 1 equal to 37 minus 12 into 3. I wrote this expression 1 equal to 37 minus 12 into 3. Now I can replace a 12 as 123. So we have 1 equal to 37 minus 3 into, what is 12 value? 123 minus 37 into 3. That is 1 equal to 1 times 37 minus into minus plus 9 times 37. We can write 10 times 37 minus 3 into 123. So we can write here 1 equal to 37 times 10 plus 123 times minus 3. So what is your x value? You see, I don't want this component. See, this is the speciality here. So be careful. I don't want this component. So we have 37, 10, 123 minus 3. We can write this as a times, sorry, I can write 37 times x plus 123 times y. Draw this x value. What is x value? My x value is going to be 10. Don't worry regarding y. We are not interested with y. Only we are interested. See, that's what we want. What is x value? 10. So we have 10 is 27. The problem is 37. Yeah, it is 37 inverse. 10 is 37 inverse of mod 123. That is the inverse of 37 mod 123 is equal to 10. If one, you can cross check. How to cross check? The cross whether 10 is a valid number or not. How to cross check? I will go with here. I will erase here. And I will show you. What is inverse? When you multiply this number with a given number, when you divide by 123, I should get the answer 1. Remainder should be 1. Let's see. So we have, consider 10 into 37, that is 370. 10 multiplied to 37, this is 37. 37 multiplied to 10, 370. Now divide by 123. So we have 370 divided by 123. Use calculator, easily you can evaluate. I'll show you. Consider 370 divided by 123. Yesterday I told you how easily you can enjoy. The answer is 3.008130081. Goodbye to this. Now multiply 123 to the decimal part. So we have 123 times 0.00813081. What you are expecting? You are checking whether 10 is going to be inverse. You are expecting answer should be 1 here. You can use calci to cross check it. I'll show you. Yes, the answer is 1. See the magic. So using calculator, many of the work you can do. 123 multiplied to decimal value is 1. The final remainder, this is remainder. Remainder is 1. Once the remainder is 1, obviously it should be inverse. So this confirms, this cross checks. So 10 is the 37 inverse under modulo. I'll take one more example and then I'll directly go to the next component, that is Chinese remainder theorem. For Chinese remainder theorem, this inverse is very important. I'll go, I took one previous example, I'll take the previous example, I'll try to work out the problem. Because you should have strong idea in finding the inverse under linear or under modulo class. Example number 2. Find the inverse of 27 mod 392. And verify your answer using this. We'll do it now. Let x be 27 inverse mod 392. This implies the modeling is when you multiply 27 to x, I should get the remainder 1 under modulo 392. Now what is the procedure? See, when you are finding the inverse of the linear under modulo class, take this number and take this number, find the GCD using Euclidean algorithm. That is GCD of 27 comma 392. This is my work now. So how to find? Again, Euclidean algorithm, which is a tabular representation where you cannot find in any of the book. Easily you can enjoy. It is B, it is A, it is R, it is Q, pardon. It is R. We can write R equal to B minus A into Q. Everything is ready. What is B? The bigger value. What is A? The smaller value. And I will do. Okay. So we have 392 divided by 27. It is 14. It is again 14. You can cross check. 27 into 14 plus 14. You can cross check. 27 into 14 plus 14 is equal to 392. Yes. So what is the R value? 14. What is B value? 392. Minus. What is A value? 27. What is Q value? 14. Now push A, push R. Again apply division algorithm. That is 27 divided by 14. The answer is 1. Is going to be 13. Now what is 13 now? We can write 13 as 27 minus 14 into 1. Now push A, 14, push R, that is 13. Now no calculation is required here, simple approach. 13 ones are 13 and the remainder is 1. We can write 1 equal to 14 minus 13 into 1. Now bring A, bring the R. 1 multiplied to 13 gives you 13 and the remainder is 0. We don't want any more. And the R value previous to 0. Once you get the 0 of R, you stop the procedure, take the previous value, that is going to be 1. GCD is 1. Once that is confirmation. Once the GCD is 1, I can find the inverse. Once you get the confirmation, you go with the extended Euclid algorithm to get your X value, that is going to be your inverse of the given problem. I'll do that now. I'll continue with this. Now I got the confirmation. What is confirmation? Do inverse exist? Yes, because the GCD is 1. Now we'll continue now. Now we go, I can write here the GCD of those two numbers, that is 27 comma 392 equal to 1, which confirms there is inverse. There is an inverse for 27 under, there is an inverse for 227 under the operator 392. How to find the inverse? Go upward. We can write 1 equal to 14 minus 13 times 1. 13. We can write 1 equal to 14 minus 1 into, your 13 can be taken as 27 minus 14 into 1. Simplify now. 1 equal to 14 minus into minus plus 14 into 1. We can write 14 into 2 minus 27 into 1. Now go up, I can replace 14, therefore 1 equal to, that is 392, I can write 2 times, we have 392 minus 27, 14, 27 times 14 bracket minus 27. So we can write here 1 equal to 2 into 392, that is I can write 392 into 2. 2 into minus 14, 2 into minus 14, that is minus 28, minus 27 into 1, that is minus 1. So we can write 20, simple mathematics. Now we can write 1 equal to 392 into 2. Say what is your expectation? You want to evaluate the inverse of 27, not the 392. Write the other way, it is always better. So we have 27 times minus 29 plus we have 392 times 2. You don't worry regarding this. You worry regarding this, but I should not have negative. How to overcome the negative? Minus 29. What is the modular value? Modular value 392. Add 392 to this. So if you are using calculator, if you add it is minus 29 plus 392. The answer will be 363. So we can write 1 equal to 27 times 363 plus 392 times 2. We don't want this. We want this. 27 already we know. This is the value you are expecting. Therefore, your x can be taken as 366. 363, which is going to be 27 inverse under modulo 3. People will literally try to find the inverse of a given modulo class. Very simple. If you understand the flow, find the inverse. This is what exactly. This is mathematical modeling, linear congruent equation. Get the GCD of 27 and 392, the given number and the divisor. This is a given number, this is a divisor. Draw those two, get the GCD using Euclid algorithm. So go rising method. Once you get the rising method, I am going to get two expressions. The expression is the given number and the expression is the divisor. Divisor, you don't worry. The given number, to that number I should have a positive multiplier. There is a negative multiplier. How to overcome? I am just showing here. How to overcome? Take the minus 29, take the negative number, add the divisor. I am going to get 363. So I got x1 equal to 27 times 363 plus 392 times 2. Now 363 is going to be the inverse of 27 under modulo. You want to cross check. How to cross check? The same approach. I can do the cross checking here, learn the cross checking and get the confirmation before going to next level. So that means, what is your inverse now? So 363 is 27 inverse under modulo 392. I want to cross check. This implies take 27 into 363. 27 into 363. 27 into 363 equal to 9801. 9801. Divide by the modulo value. So we have divided by 392. I got 25.00255,102. Goodbye to this. Just multiply. I am going to get here 392 multiply to 0.00255,102. If you multiply into 392, you are expecting the answer is 1. Yes, answer is 1. See the beauty. So my mathematics, once you have a nice control on the flow, nowhere you go out of track. You can enjoy every part. So I explained linear congruent. I took one case study where you can find many solution. What is the many solution approach? We have x is equal to x naught plus the n divided by g times t, where t has to run from 0 to g minus 1. Using this, I went one step ahead of finding the inverse under modulo class. Once you understand these two, my major application of number theory is going to be Chinese remainder theorem will work now. Okay, I will go with the Chinese remainder theorem. After that, I may go to formats and Euler's pi function. If time permits, I come back and I will do linear Diophantine equation and one problem under cryptography. It all depends on the time parameter.